my name is Xenon. I'm here to show you how to use blend shapes and bone transforms to make customizable characters, or how to make your own monster factory. By Xenon, me. Here's a little preface. This is how I do it. Feel free to tweak or modify to suit your project, as I do with every single tutorial and advice I come across. First of all, we're going to be modeling and rigging in Blender. Then we're going to import that into Unity. And after that, we're going to use C# code to identify and modify the model's change points. This will not be a full Blender, Unity, or C# tutorial. I've only got so many minutes. So it's going to assume some basic knowledge in these programs, but hopefully everything will include enough terms and starting points that it should be easy enough to Google for more information. Here are some recommended tutorials. These are the starting points that I used when I started this journey in making my own character creator. I used these as starting points and then went from there. All right, so we're going to set up our mesh and our rig. Whatever character you want to make, I recommend doing separate meshes, especially if you're doing a cartoony character with a flat or cell shader. It's going to save you a bunch of rigging time if you have separated meshes. For the hands and feet, I recommend the arms and the legs, the head and the body torso especially. Those things can hold so many blend shapes each, so you'll definitely want to have those separated. We want closed and rounded cylinders for the separate arms and legs specifically, so that when you rotate and animate the character, we're not going to see any of the internal geometry. For texturing, here's a little tip. The Text Tools add-on is going to let you rectify your UVs. So it's going to automatically arrange your UVs into a nice rectangular array. I like to rectify to make the textures easier to read and therefore add new patterns to. Don't separate your meshes too much. I originally had the elbows and knees also separated into cylinders, and that was a pain in the butt to texture, so watch out for that. I like to use Photoshop to draw my textures, so that's also why it's very important to have these nice rectangles, but it might be faster to use Blender's inbuilt texture drawing tools or any other drawing program. Just use what you're comfortable with. For the mesh and rig, I want to make an important note. You need to make sure that when you're putting your LNR designations, that you put them at the very end of the bone names. This is so that when you mirror something, Blender is going to auto mirror the weights and the UVs for you. If you don't put it at the very end, you're going to have to do that yourself. For the mesh and the rig, I like to add extra bones on things like arms and legs that will let you scale things independently of the bones down the chain. If you just use the base bones for scaling, it's going to scale everything down the chain, and that might not be the effect you're going for. So once you're all done with everything, you can go ahead and rig it up. I haven't used Blender's auto rigging thing because with the separated meshes, it's super easy to just make sure everything's assigned to each part. And then you'll want an idle pose at least, so you can make sure that the rig's decent and everything's playing nice in engine later, but feel free to add however many animations you'd like. Okay, now that you've got your mesh, it's rigged, it's time to get our blend shapes modeled up. Duplicate the mesh you want to make a different shape for. You're going to modify it how you like, keeping the same number of vertices, and apply it to the mesh. If you have clothing or a transparent cutout mesh for face features, do the same, making sure there's no clipping. And you'll want to make sure to give any blend shapes that correspond to the same deformation the same name. So we need torso lean and torso fat blend shapes for both the torso mesh and the shirt mesh. And here's a little tip for making sure that everything's working nicely together. If you set up a driver in Blender for your matching blend shapes, it will mean you just have to change one mesh's blend shape to change the others. This is great for testing if everything matches correctly in Blender. And then it's pretty much all done. Time to get it in the engine. Almost. I've got one more tip for you. If you want to set up your blend file directly in your Unity project, it will help you a lot. So I like to make lots of backups. So my blend file is full of duplicate meshes and previous versions. In order to not have those import into the project itself, I edit the file that tells Unity how to import Blender files. It's called Unity-Blender to FBX. It's usually located in this section of your hard drive. Before editing it, don't forget to make a backup. I've modified mine to ignore any objects with a dot or underscore at the front of its name, and this will let me modify and tweak stuff in the blend file and have multiple copies and backups of meshes without clogging up the amount of meshes that Unity indexes. Because I'm the type of person who has a huge Photoshop file with millions of grouped name layers with copies of each edit I make, just in case. So your mileage may vary with this, but Keeping and modifying the blend file itself saves me from having to re-export an FBX every time I change or add something. I just have to click Control S. Woo, workflow efficiency! Okay, now it's time to set up our code. I recommend just setting up enums for all sorts of things. You want an enum that matches all of your blend shape names. You can do separate enums per mesh if you have a lot, like some for the head and some for the body. But in my project, I just throw them all in one. You want an enum that matches all of the bone names. If you have dots or periods in your Blender file bone names for readability, you'll want to ignore them here because the enums won't accept them. We can get them out of the game objects from the .blend import later. You want an enum that matches all of the body part types, so face, head, arms and hands, that sort of thing. You'll need a few more if you have separated meshes for arms and legs. You can probably make a script that auto-generates bone and mesh enums. I do that later for the traits we want to modify, but for bones and blend shapes, I write them all out and error check for typos later. Just a quick note, I have a lot of code examples. Anywhere I zoomed in, I removed the furry from stuff to make it easier for reading, so have fun spotting all of those. All right, so it's time to make our custom trait class, so that we know what to change. It's going to contain the name of the trait, what type of modification we're doing for this trait, the maximum and minimum range, the value it's set out now, and the various enums that relate to it, so we know what type of modification we're going to do. So here's an example declaration of one of these traits. If we're going to change the hand size, we'll need to know that it's modifying the scale transform, that it's working with these specific hand bones, the hand scale L and hand scale R in a little bone array. The default scale transform value is 1, the minimum value is 0.1, and the maximum value is 0.4. All right. So once you have declared one, it's time to declare a whole bunch of other ones so that we know all the sorts of things we're going to be modifying. Compile as many traits as you'd like, or just a few for testing at first. You'll add them all to a dictionary of string names and then the actual character trait class that it's associated with. And then you'll copy this whenever you need to make a new character creator. I also, when I'm building these, build a list of strings that go alongside them, and then I feed those into a script that makes an enum file for me if I tell an editor script to run that for me so that I get even more enums out of it. Once you've got that all set up, it's time for front-end code. So at start or runtime, you want some kind of model data script attached to your prefab blend file that pairs up your enums to the relevant game objects using dictionaries for each set. Blend shapes, the bones, and the body parts, so that all you have to do to find the skinned mesh renderer is reference that enum. So that's why we're hooking all of this up this way. So if you named all of your enums the same as your bones and blend shapes and meshes, you just check for those when you're looping through, and it should be pretty easy to hook everything up in an accessible way. And then I also have a dictionary of traits that we have to animate every frame. So this is going to be your bone transforms. You're going to want to change those every frame. I have those in a separate, just a list of the names of those, so I know which ones to change every frame. So before we loop all of this stuff, we want to take our .blend prefab that Unity has processed, unpack it, because it's going to have a lot of duplicate meshes in there for like hands and heads and stuff. And we don't want all of those game objects at runtime at the same time because that's going to waste memory if we have a lot of monsters in the same place. So we want to get it just down to the basic default, one hand, one head for all of that, and then make a new prefab that also we can add any scripts to, like the model data script that will loop through these things and get them for us. We are hooking it up by looping through the .blend prefab, and because everything's named the same, we've made sure the enums and the game objects are named, if not the same, pretty similar, so any periods we can strip out and throw those away. Then it's just looking at those and being like, okay, this is named this, so it's referencing this enum. And then we're doing that for both the bones, which is pretty easy, and then for the game objects with the meshes, usually what I do for the front part is say, okay, this has feet in it, so it's a feet body type. Or if it's a hand, it's got a hand body type. So that's the enum that we want to reference. Here is my little function that updates every frame. It goes in late update because that means the bone transforms are set on top of the existing animations. So it'll play the animation transforms first, and then I add the scaling and the transforms after that so that it applies whatever traits you want to it. In order to change meshes, because we deleted stuff in the blend prefab before, you're not going to be like turning off game objects and turning on ones that you want. If you want to re-add something, you can't just spawn a new skinned mesh renderer. Unity doesn't like that. It needs you to copy an existing skinned mesh renderer already applied to that armature. But if you are just swapping like bunny ears with cat ears, you can use resources.load or Unity's addressable system to swap that mesh with the skinned mesh renderer's shared mesh. So all these tricks together, and you can create a monster. But don't just stop at one monster. You can make like a dozen at least, maybe even hundreds or like millions of them. The possibilities are absolutely endless, and enjoy making them because I know I do. You can find me online at xenonfossil.games, where you can wishlist Creature Creation Station on Steam. So just go to xenonfossil.games. And thank you for listening. I've been Xenon.